Before diving into the world of machine learning or artificial intelligence, it's essential to understand the foundation, data. AI doesn't think independently, it learns by recognizing patterns within data. The quality and type of data you provide directly influence how effective your AI system will be. Imagine AI as a brain that's only as smart as the information it receives. Good data leads to good AI, while poor data can result in unreliable outcomes. In this video, we'll explore the two main types of data, structured and unstructured, and why this distinction is more important than the algorithms themselves. Let's start by seeing how data powers AI and why it's the backbone of every intelligent system. Data is simply a digital representation of real-world information. It comes in many forms: numbers, text, images, audio, and video. Each type of data is handled differently by AI systems. For example, numbers might be stored in spreadsheets, text in chat bubbles, images as photo thumbnails, audio as sound waves, and video as play icons. Understanding these basic data types is crucial because AI models process and interpret them in unique ways. Whether you're working with sales figures, customer reviews, or photographs, knowing what kind of data you have is the first step to building effective AI solutions. Let's look at how these data types appear in everyday digital life. Structured data is highly organized, typically arranged in rows and columns. Think of a spreadsheet or a database table. This format makes it easy for computers to analyze and process. For example, a customer database might include columns for ID, age, country, and number of purchases. Structured data is everywhere: bank transactions, sales records, sensor readings, and more. Because of its predictable format, structured data is ideal for traditional machine learning models like regression and decision trees. These models can quickly find patterns and make predictions based on the clear structure of the data. Let's visualize how structured data flows from tables into machine learning models to generate predictions. Unstructured data, on the other hand, doesn't fit neatly into tables or spreadsheets. It lacks a fixed format and can include anything from emails and documents to photos, videos, and voice recordings. In fact, over 80% of real-world data is unstructured. This type of data is much harder for computers to process, requiring advanced AI techniques like natural language processing for text and computer vision for images. For example, AI might analyze a collection of emails to detect spam or use neural networks to identify faces in photos. Understanding unstructured data is key because it represents the majority of information AI must handle in the real world. Between structured and unstructured data lies semi-structured data. This type of data has some organizational properties like labeled fields, but doesn't conform to rigid tables. A common example is a JSON file, where information is stored as key-value pairs. Semi-structured data is widely used in APIs, web applications, and system logs. It offers flexibility while still providing enough structure for computers to parse and analyze. Recognizing semi-structured data is important because it bridges the gap between the clarity of structured data and the complexity of unstructured data, making it a frequent choice in modern digital systems. Let's summarize the main differences between structured and unstructured data. Structured data is organized in tables, making it easy to process and suitable for classical machine learning models. Unstructured data is free-form, complex to process, and often requires deep learning techniques. Semi-structured data sits in between, offering some organization but not strict tabular format. Understanding these differences helps you choose the right tools and models for your AI projects. A clear comparison makes it easier to decide how to handle your data and what challenges you might face. AI can't learn directly from raw text, images, or audio. Instead, it must convert these forms of unstructured data into numbers that models can understand. For text, this means breaking sentences into tokens and then turning those tokens into vectors. For images, each pixel is represented as a number in a matrix. Audio is transformed into waveforms and then into features. This conversion process is essential for enabling AI to process and learn from the vast amount of unstructured data in the world. Without it, AI would be unable to make sense of the information it receives. It's a common misconception that more data always leads to better AI. In reality, the quality of your data is far more important than the quantity. Clean, accurate data helps AI models learn effectively, while dirty or biased data can introduce errors and lead to poor predictions. Warning signs like missing values, inconsistent formats, or biased samples should always be addressed before training your models. Focusing on data quality ensures that your AI system is reliable and trustworthy, no matter how much data you have. A typical AI data pipeline involves several key steps. First, raw data is collected from various sources. Next, it goes through cleaning to remove errors and inconsistencies. The clean data is then encoded into a format suitable for machine learning models. After that, the model is trained using this processed data. Finally, the trained model makes predictions based on new inputs. Understanding this pipeline helps you see how data moves from its raw form to actionable insights in AI systems. Many beginners make the mistake of skipping data cleaning, using overly complex models on poor data, or treating unstructured data as if it were structured. These errors can lead to unreliable AI systems and wasted effort. Always start by understanding your data, cleaning it thoroughly, and choosing the right model for the data type. Avoiding these common pitfalls will set you up for success in your AI projects and help you build more accurate and effective solutions. To truly succeed in AI, always start by understanding your data. While algorithms are important, the data you use is even more critical. Remember to identify your data type, clean your data, and choose the right model for your needs. By focusing on these fundamentals, you'll build AI systems that are accurate, reliable, and impactful. Stay tuned for the next lesson, where we'll dive deeper into data cleaning and preparation for AI.